Hi, everyone. My name is Gabby Gitsa, and I am a software architect coming to speak to you on behalf of Adobe. I hope everybody can hear me okay and see me okay. Yeah, thanks for your patience with the technical, while we sorted out the technical issues. Let's get right into it. The main reason I'm here is to talk to you about a new feature that we launched in Photoshop this year at Max. It's not even a month old. It's just a few weeks old. It's getting a lot of mentions. There's a lot of talk about it on the internet. And the name of the feature is Neural Filters, right? From the title, and it's officially it's called this creativity platform powered by AI for creative tool control reinvention. So that's kind of a mouthful, and it sounds like marketing spiel, but there's a lot of truth to it. Now I'm really not going to demo this very formally. I'd rather show you this in a more informal manner because the feature is really very fun to use. So what I've prepared here are a few examples of what neural filters can do, because we've got a lot of filters in here, and each one does different things. So without further ado, let me share my screen. All right. I hope everybody can see my screen. All right, and I have confirmation that it's visible. All right. So what I'm going to do, I have Photoshop open here with a few photos, and I'm going to open up neural filters from here from the filter menu. And I'm going to show you a few filters. All right, so let's start with the first one. This is skin smoothing. We're going to have to zoom in a bit for this to really show. And let's set the smoothness to max and the blur to like 70 something. All right, so I'm not sure how well this translates through the video share, through the video conferencing, but if I toggle this on and off, you can sort of see a blur around the face. I intentionally turned the blur all the way up, so it's really it's more apparent. All right, so this is machine learning powered skin smoothing. We detect the face. We use machine learning to detect the face, the facial landmarks like the eyes, the eyebrows, the mouth, the lips, right? And we apply the smoothing on the skin, right? A bit of Gaussian blur and some smoothness that's machine learning driven. All right, and basically that's how you get this effect. We'll talk about this more later in the demo. I'm just going to show you more high level right now. I just kind of go through the filters. All right, so that would be skin smoothing. I'm using a bunch of different pictures because they're to highlight the effects better. So switch to this picture of Big Ben. And already you can see that it's detected no faces, so there's no skin smoothing here. It's kind of grayed out, and all the face filters are going to be grayed out if you open a photo with no faces. All right, but this one is not. This is called style transfer, and it's basically a way to restyle your pictures, your images in the style of another image. And you've got a bunch to choose from here. You've got like famous paintings, things like that. Right, or even like more edgy designs. So some of these will take more than like a second or two to process because it's machine learning, so it depends on your hardware. Some of the filters are powered by the cloud, so you need to talk to the Sensei platform, but more on that a bit later. We've got some matrix styles here as well, and a bunch of other sliders here to play with. Right, you can blur the background, etc. All right, so that was style transfer. And I move on to this next photo. This is dark hedges in Northern Ireland. And it's got a bit of creepy, spooky feel to it, right? But really the reason I chose this picture was because it's got a lot of depth to it, right? So now we're gonna look, if we go into the beta filter, so this is a bit of a first for Adobe. We typically release things when they're ready and working 100%, or we're super happy with the results. But here we're with the filters, we want to take, with NeuroFilter, we want to take a different approach and kind of gather feedback, open them up to users, and develop them or improve them afterwards. So we're releasing these as beta, and this one, DepthAware Haze, will detect the depth in the image and add haze coming from afar to up close. All right, so you can see as I increase the haze, it's coming closer to me, right? And as I decrease it, it goes further away. And you can do this with shots, like if you have a subject in the middle and you have a background, like you're somewhere in the mountains, right? And you take a wider shot, you can use this effect to add haze. And you can also control the warmth of it. Right? You can have it like a colder, or since it's more of a creepy, like spooky, hellish, right, warmer tone. So there's a lot of fun to play with this, and you can really make your photos stand out with just a few clicks. All right, next one, also a beta filter. So let's say I have a black and white photo, and there's a lot of work to recolorize black and white photos, but if you just use this filter, you get a lot of the work done for you. And it's basically, so this is machine learning powered colorization. And of course you can sort of tweak like the sliders here to adjust the values, but I think this one came out pretty good. What you can also do is, let's say I remember this car being, I don't know, blue. So I can just do that and click on the car over here and put a little dot here that gives it a hint to colorize this in blue. And again, you can play around with these. You'll get different results. All right, so that will be colorization. And one of the main filters that we're looking to release, once it's really once it's rock solid, is Smart Portrait. And this filter, it's got a lot of configuration options here. This allows you to change facial expressions. It allows you to change facial age, gaze, the hair, where the person is looking, where the light comes from. So there are a lot of options to play with here. But I was thinking, I've got this picture with the Game of Thrones cast, and we know that Jon Snow is kind of a brooding character, so we thought we'd do something never before seen. We're gonna make him smile. So let's see how that works out. So it takes a bit. Like I said, this one, some of the filters process the data in the cloud, and this one requires to talk to the cloud when you first when you show it a new face. to get some data about that, and then be able to tweak the parameters. So once you are finished with the first slider, there we go, much better. All right, so once you are finished moving the first slider, the next calls are going to be faster. So we can combine these. We don't need to just add the happiness. We can also say increase facial age, and I'm gonna make him a bit older. All right, and you can tweak a bunch of other sliders here. Like there's a feathering slider here for how much to blend with the picture, like how much from the output to get versus from the original picture, like say for the hairline here, right? So you get more hair. Or if the mask is kind of to the side here, is offset a bit, then you can use this offset slider to move it up or down. And there's this other slider to retain the unique details in case the identity doesn't seem to be preserved. You can play around with this. This is still experimental, so I'm just going to leave it the way it is. All right, so that's Smart Portrait. Next up, we've got makeup transfer. So let's move to another face here. So here you can load up a reference image. You can either select one from the disk, or it shows you the images that are already open in Photoshop. So I'm going to pick this image. It's going to show it to me over here. And it's going to transfer this makeup style. Oh, it already did faster than I was able to talk to it, to the selected face. So I chose this makeup style to kind of make it go better with the hair. All right. And as you can see, I'm actually combining. I can actually combine the filters, and I can see them here, all the applied filters in one list. So let me turn these off, and let me show you another one. This is kind of like the kind of like in the movies where it goes enhance, and it increases the details. It zooms in and increases the details. So this is something like that. It's more geared around faces. So let's do like an 8x enhance over here on the eye where there's a lot of detail. So we'll wait for a bit for this model to run. And if you have a faster machine, this will run faster. I'm just on a laptop right now, so it's not as performant as a high-end machine. All right, so we can further refine this image. Since the input was a JPEG, we can also remove JPEG artifacts here, and we do the enhancement plus the removal of JPEG artifacts. And to see what it would look like without, you can just do this, and you'll see that it's a bit more grainy now. But again, this might not translate that well. This graininess effect might not translate that well through conferencing, just because of the nature of video compression and all that. But you can play around with these. You can use your own images, your own sample images, see if you're happy with the results. Again, these beta filters, they might work better with some images and not so good with others. Like for instance, super zoom is more geared toward faces and might not bring out the detail in like everyday objects. And also, you also have JPEG artifacts removal as a separate filter with some options here, like low, medium, high. All right, so those are the filters. Those are pretty much the filters that we have right now, and I've showed you a bit of what they can do. So let me talk about the neural filters project for a bit. So this feature, feature is actually, being in Photoshop, you think that Photoshop is like a 30-year-old app, so you'd think that it's I don't know, built with I don't know, C++ and all of that. And there's a bit of C++, of course, but the panel here has been built with web technologies, like with very modern coding languages and technologies, like HTML, React, JavaScript, and we do all this on top of what we call the Unified Extensibility Platform, or UXP for short. So UXP is something that we integrate into a lot of Adobe apps, and it enables you to write your apps as you would for a browser, with some additional APIs, of course, for integration. But at least in terms of layout and being fully compatible with JavaScript, and being able to use technologies like React or Redux, etc., you can build very modern UIs inside 30-year-old apps like Photoshop. All right, and when I say they behave like in the browser, I mean it. If you squeeze this panel, it's actually responsive, right? And it's just done the old way with like media queries and things like that, right? So, or not the old way, let's say the standard way. So basically, we have it's not really a browser, it's not really a web view, it's something native. So at the end, when it has to paint the elements, it's going to use whatever the host app provides. So there might be some, like a translation layer between that, between EXP and the app. But again, that's I don't want to get too technical about that. Suffice to say that this was an effort that was supported by the Photoshop and UXP teams, who provided the platforms that we needed to build the application and integrate it properly. We have also help from the home screen and unified panel teams, who supplied deep links into the application, so you can actually click on buttons in the home screen here, like from the what's new, and you have deep integration into the neural panel. There's also, from the unified panel, you have some quick actions available depending on the image type. It'll suggest certain filters to apply, and it will detect whether filters were applied or not. So we have this sort of interoperability integration. There's also there was a lot of, like, a massive help, obviously, from the research and ASML team, from the Sensei platform. Of course, some models run in the cloud on the Sensei platform. Some models run on device. And a lot of the models started out being built by Adobe interns and intern teams. And with our help, with the help of more senior engineers, we've refined them and got them into the product, right? And to talk more about this experience and how interns have contributed to this project, and what goes on behind, on the like at the lower level on the machine learning side, which is not my forte. I'm just a UI guy. I'm going to introduce Tuan Feng, who he himself has started as an intern at Adobe. So take it away, Tuan Feng.
Cool, thank you. Let me share my screen. Yeah, so can you see my screen now? Okay, so yes, thank you, Gabby, for the introduction. So for me, I'll take like 15 minutes to briefly talk about the Adobe products with perspective from research, and especially introduce this Adobe Research department and present some recent progress from our lab. Yeah, my name is Chuan Feng. I used to be an intern in Adobe, and now I'm a research scientist in Adobe Research London office. So yeah, so Adobe Research is relatively, it's not too big, but it's a very big department. We have about 200 scientists, plus engineers and artists. We have office all around the world, like in the major United States cities. San Jose, we have headquarters there, and Seattle, San Francisco, Maryland, Cambridge. We also have a newly started office in London, also an office in India. So for the whole Adobe Research, we're looking at several very popular but also very challenging directions, say for the artificial intelligence and machine learning. And you can see as the product that Gabby just showed, there are a lot of algorithms that actually running on the cloud. There are machine learning algorithm and other progress of the AI related things that support such applications. And we're also working on this AR, VR, and the 360 photography. Like in many Adobe products, say Illustrator or Dimension, like you need such technology to interact with user. And we also work with audio to allow the machine to understand and synthesis what people are talking about, and computer vision, imaging, and video. This is like very popular actions. There are a lot of progress here, and as you know, like one of the main products from Adobe is this Adobe PDF. So we will also have a lot of interest in this content data document intelligence. We also work with like graphics in both 2D and 3D. For the application-wise, we have apps like Arrow, and also for the Dimension and some Illustrator, we also have some 3D and 2D things. For human-computer interaction, this is like you'll know what it's about, and intelligence agents and systems like smart QA system, and also neural language processing, the NLP, that allow the machine to understand the text. And yeah, the more fundamental things like systems and languages. So there are the whole lab is focusing on. Like for me, I'm from the London office, and my experience is more about the computer vision. I marked red here, the computer vision, imaging, video, and also graphics. Yeah, so during my talk, I will like briefly present what is going on in our London lab. So there are 4 projects to talk about. One is this Starflow. So this Starflow is basically the technology that's behind the neural filter that Gabby just presented. So this is a collaboration between Adobe Research and the university. So people have working on this direction for a couple of years, and we will formulate what the outcome into a research paper and published. And later on, people will pay a lot of efforts to do the tech transfer to make part of the research paper into the product. Like there's some reasons because it's for the robustness and the efficiency. There are many other things. So here we can show some example. Like in this paper, we can change the illumination and orientation and also the identity of a visual image. And because this is for research, we will also evaluate our methods with different data sets. Say for example, for the car data set, we can change the view direction and also the appearance. Like here, I change the color. Just note that it's not simply the color, because the material are very specular, so it will be very difficult to capture the variance of the reflection. And also here we change the identity. It's quite different from face, but you got the concept that the modification is just quite similar. And we also need to do other evaluation, like for example, this one-to-many transfer. We can transfer from the same image to different sources and to ensure the consistency. Yeah, so as a research paper, like we will describe the technique in more detail, like how the whole architecture behind it and how you train it, like where's the data, and also we need to do a lot of user study to show that, because this is a big problem and it's actually one of the open problem in this area. So a lot of people know that this is something that people should work on, and there's a lot of previous work. So we did user study to compare with our work to the previous work, to ask the user to say which one is better, and they can see from our histogram that ours performs quite nice. And also the failure case, as a research paper, you need to somehow understand the limitation of each method. And for the left bottom, you can see that we try with very challenging cases and show that ours get better performance. And also, like for the interpolations, we will try with different methods, and even the difference is subtle, and we still need to somehow evaluate the performance of different options. Yeah, so yeah, this is just basically give you a feeling that the difference between a research outcome and a commercial product. And yeah, so the next thing I'm going to talk about is pattern composition. So for many softwares, Photoshop or Illustrator or InDesign, will sometimes work with these patterns. The problem is when you edit this pattern, there will be a lot of holes and also like missing pattern, like the yellow leaf. So it will be difficult to fill this hole or complete the missing part. This will take a lot of time and efforts for the designer. So what we did is, yeah, this is also a collaboration between the university and Adobe Research. What we did is, once you provide the pattern image and also the element type, we can automatically detect the elements from the pattern and understand the layered relationship between them, and like which one is in front and which one is in back, and what's the relationship between them, and how the patterns are structured. So by doing that, we can somehow understand this pattern and enable very efficient editing of the image, and also say add 3D effects and and extend a small pattern into a very large pattern. For example, here, so we can easily drag the whole object without affecting others, and you can see it's had a very nice overlap between the other elements. And yeah, see, we can select all the relative patterns. And like for here, we because we know the relation, we know the structure of this pattern, so we can enable some very cool 3D artifacts, 3D effects. Yeah. So yeah, just as I said, because you know how this pattern is formed by the elements, we can easily extend this pattern into a much bigger one. This is not just simply like repeat the pattern in a 2D style, but because if you do that, you will have a very unnatural theme, and also the visual quality will be bad because things are just repeating itself. But if you know the structure of this pattern, you can somehow synth this with a more intrinsic property. So the output pattern is more natural than just simply repeated in 2D. Yeah, so yeah, so this is something that we have just published this year, and hopefully you will see it in the next version of Photoshop. So the next project is about this hair synthesis. This is published to CVPR this year. What we do is we can compose the hair. When I say hair, I mean the bread and the real hair of a human face. So like here, once a mask is given, and you can give the flow of the bread and also the shape of the bread, and the system will automatically update the 2D effects. You can also change the color. This is a very difficult challenge. This is a very difficult problem, and there's a lot of challenges because when you change color, it's not just simply replace the pixels. It needs a deep understanding of how the bread structure is how the beard is structured. And also for here, we can change the orientation of the curve, and by doing that, we can also change the appearance. And yeah, as a research paper, you cannot stop at from code demo. Like you need to fully evaluate the approach. And for here, we just test with many different edits, and you can see that the proposed method is quite and can apply to many different scenarios. And yeah, for the last part is about this garment design. So yeah, I'm involved in this part when I was an intern. It's actually still a collaboration between Adobe and the university, but it's just at that time I'm still at the university. So yeah, so in this work we are trying to establish a pipeline that allow the user to model a 3D garment with simple sketches. And the parameters, semantic parameters, the dimension of the garment or body, or for example, the length of sleeves, things like that. And we can edit the texture and do the style transfer, the garment transfer between different body figures. So, like for here, we allow the user to generate the garment from a 3D sketch, and you can edit the sketch. Yeah, for here it's just change of the texture. And you can edit the sketch. Say you want to make the you want to make the sleeve shorter. And also maybe you want to make the cloth more fatter, and yeah, the system can update the 3D garment in real time, and also you can add some new folds. It also can be created, so it can also retarget one design to different body figure. Like this is called grading. Like traditionally, it will take many time to do that, but with our system, it can do it in a fully automated way. And we allow the interpolation of the cloth. This is quite useful for some design purpose. And here we show that our method can also work with different type of garments with different type of input. Yeah, so we just mentioned this is an internship project. Started like started at the third year of my PhD, and it takes about so typically in Adobe Research, there will be an internship opportunity for every summer. Here's a shameless advertisement that we are hiring. This actually starts now for every November. The petitions will be open. And the internship was for 3 months for the next summer. Since the COVID situation, the internship will be remote for the next year, and you will be paid by Adobe and continue the project for 3 months. And after that, you will continue working on this, and eventually we will have something published. And after that, we will see that if there's a possibility to transfer it into the product. So that is the whole thing. The whole pipeline was established, and yeah, so I can show you something in more depth about my internship. So at the very beginning, we're actually imagining something quite different. Say we were still working with this sketch to design pipeline, but the way we do it is quite different. How we will also think about how to understand the illumination based on the shading of the faults, and also how to get the geometry from the texture distortion. And of course, this failed. And we also tried a lot of silly experiments to understand the interaction of the garment in a physical-based setup, how it interacts with itself or interact with the body. And yeah, after like about 10 months, we eventually come to what we have now. So yeah, so this is basically the story of this project. And yeah, this is what I'm going to talk about today. Thank you for listening. I think we can move to some QA session.
Hi guys, it's Lizzie from Reach My Placement here. Thank you so much for all of that insight and really interesting stuff that goes on behind the scenes that no one ever probably sees. So we've probably only got a couple of minutes for questions. So I just wanted to dive straight in. Lots of students will be thinking, how the hell do I work for Adobe? So it would be really lovely to hear from you about what do you think are the best things about working at Adobe? Gabby, can I come to you first, if that's all right?
Yeah, sure, absolutely. I think there are a lot of interesting projects to do, and you can really get creative, right? So there were, as you can see, right, with neural filters, it was like nothing was off the table, right? We looked at anything we could do to boost Photoshop with machine learning, and there are a lot, and I mean a lot, of talented people. There was never a moment where I felt that I was the most intelligent person in the room. So I don't know if that makes sense.
Yeah, definitely.
So you always have something to learn from other people, and they're quite nice too.
Always helps. How about you, Tuan Fang?
Yeah, actually, I have the exactly same answer in my mind, because as a researcher in Adobe, because Adobe Research has established for many years, and it has attracted almost the top researchers all around the world. So being Adobe Research, you can like collaborate with the best people in this area, and also, yeah, this is great. Especially for the beginning of my career, this is a fantastic opportunity.
No, it's brilliant to see what you've been working on, and it's just really interesting. Like, you don't see any of this Adobe work until it kind of comes out in a different forum. So brilliant. And we've only got like one more minute left. So I guess the other thing, just to build on that I think is really important. A lot of students are thinking they're trying to work out which company to apply for, and obviously in this, there's lots of different companies out there and lots of different skill sets, etc. So it'd be really interesting just to understand, like, what inspired you when you were looking? What inspired you to really work and choose Adobe? Building on that last question, that'd be great. Gabby, what would you say?
Well, to me, it felt like a very like this opportunity that I couldn't pass on. I mean, I was previously working for another company, and I was there for like 12 years. But it only took like an interview and talking to the people here to know that this isn't something I want to pass on. So, and it was a hard decision, I have to tell you, but they won me over. And I'm really happy with that decision. I've been here for almost 2 years, and so I have like 15 years in total experience. So it's like 13 years there and 2 years here.
Wow.
Yeah.
Lots of knowledge. Sure. And yeah, what would you say? What attracted you to Adobe when you were looking, Tuan Fang?
Yes, the word come into my mind is creative. So Adobe got a lot of products and a lot of experience in this creative related work, and this is quite attractive. And yeah, and like human are visual animals, so we look at things throughout the day, and we're pleased by the things like look cool, and this is definitely Adobe is working on. So this is quite important, and makes me choose this opportunity.
Awesome. Well, thank you so much. We're out of time, I'm afraid, but it's been very, very informative, really interesting. So thank you both. If anyone's got any questions in the audience, please head over to the Adobe booth, and there'll be some representatives there to answer them. But thank you again, and speak to you all soon. Thanks very much.
Thank you. Thank you.
Bye.